All right, so this is the homework for next week, one of them. This is Programming Structure Worksheet. So all it is a way for us to basically figure out how computers talk a little bit better than we already know. You're writing literal instructions for each of these items, okay? The worst thing you're going to do is overthink this and think it's more complicated than it is. It's very simple if you break it down into the steps, okay? So number one, list the steps required to fully put on your shoes. You can't simply say grab your shoe and put it on, because if we're talking to a computer, the computer doesn't know exactly what that means. It doesn't know what put on means. It means put on your head, put it on the table, or what. So we want to be as literal as almost possible. Okay, we could be even further and have another 50 steps in here, but you don't want to do that. All right. So in this case, I'm saying grab your right shoe. If necessary, untie the laces. Loosen laces slightly. Loosen the tongue. Slip right foot into the shoe, toes first. If necessary, lift the tongue, tighten the laces, tie the laces, repeat for the left shoe and left foot. Okay? So if we're writing a program, that's what we're thinking about, are all of these little steps that would go into writing that actual program. When we get to this next one, write the steps necessary for opening a door. So what's the first step for opening a door?
Grabbing the handle, or opening your hand, moving your hand toward the handle.
Okay, keep going.
You want to get, closing your fingers around the knob, turning them left or right depending on which way the knob wants to go, and pushing or pulling depending on what kind of door it is.
And you forgot, check the locks. Okay, but you had the rest of it was good. Okay, we don't need to get exact open your hand, close your hand. If we were writing a program, we definitely would. Okay, we would definitely have to give it specific coordinates as to where to move and all that. But as far as check if the locks are locked. If they are locked, unlock them. Grab the handle, turn it clockwise or counterclockwise, and then push or pull depending on what it is. Okay. So that's how it's as simple as I wanted to make it. Okay, it's just literally how do you do it. Okay. So write these. I'm not going to be looking for a specific answer. There is no exact answer to any one of these. Everyone's going to have their own. I just want to see that you're going through the process, that you're thinking in that fashion of literally what is the step-by-step process that we would go through to do that. Okay? Simple enough? Okay. It might, just make an attempt at it is the big thing. All right. Then the other part. So the concept of this one is that we're showing growth. Okay. So you're going to be drawing a flipbook, a frame-by-frame animation showing growth inside here. All right. Now it can be any kind of growth. I had one of these, because the other class is on a different schedule than you guys actually missed today. One of these where they show this girl growing her hair. Okay, so that was a kind of cool one. And then I had another one. This one was growing a snowman or building a snowman, same kind of thing. Okay, so you can see there's a snowman in there. All right, you're going to use at least 60 pages. Everyone can count to 60, so that shouldn't be a problem. And then you're just going to draw something relating to growth. The last page is where your last image should be, and that's where you should actually start drawing it. So you're going to start drawing it backwards. Okay? So if you want let's pretend we're doing a tree. We want a tree in here. We're going to draw the tree fully grown on the last page, and then when we close the next page, we can see where the tree is through here, and then we can draw the tree a little bit smaller and the branches kind of tucked in a little bit more. And then we flip the next page, and then we do it again, and then we do it again. Okay? You want to have some sort of guide. So I recommend that you go to Google and you type in whatever it is you're looking for. Plant growing. As an example, plant growing. And then you can see, not frame by frame, but you get the stages of it. Okay? Or you can do tree growing. Or that's a pretty good drawing. And then you can see the different stages for the tree growing. Now you're not going to use just those 5 images. Those are going to be kind of like your markers, your keyframes, and in between those you'll set it up. So pretending that we're going from this is frame 1 on the far left and this is frame 60 on the far right, we'll just interpolate, we'll draw what's happening in the middle of it. Okay, so you don't have to follow it exact, but as a guide, that's where you could start it, is by using that. Okay, just for fun, what would happen if I just typed in growing? Look at that, it's weird. So lots of plants. Like I said, you don't have to do plants. You could do a person if you wanted to. One guy did the plant in the Mario thing. So he plants the seed, and the seed opens up, and this plant's growing, and you see him coming out of a tube, and it's the plant from Mario. Just kind of cool. Okay, you'll need one of these to know when you hit turns. So that's that. 60 pages in here. There's more than 60 pages, so you're not going to use the whole thing. You can rip off the front if you want to save it for something else. The point is just to kind of see that process of going through and doing a frame-by-frame animation. It's incredibly powerful tool. YouTube, there it is. I lost my train of thought because I saw RealFlow and I got excited. Stop motion. Everything that we do in animation is all started with stop motion stuff, or these frame-by-frame flip books, or if you go really, really far back, they just had this like cylinder thing with a slit in it, and they had a bunch of pictures on the inside, and they would spin the cylinder and look through the slit, and they would see the horse running or whatever it was. Right. All right, so this is some sort of stop motion parkour. We'll just see what happens here. So obviously there's no other way to create this kind of animation without doing that frame by frame animation. So they're actually just laying on the ground, but it looks like they're moving around. It's pretty cool. That's pretty wild. So they're all over the place. If you go to YouTube and you type in stop motion anything, you'll get stop motion things all over the place. There's lots of movies now that are stop motion. Frankie Weenie was like a stop motion. The Lego movie was animated in 3D but stop motion-esque style. So it is all over the place. What was that? Wallace and Gromit, definitely. I don't have the patience to do actual stop motion stuff because it's a very precise thing. You literally have to make sure everything to the millimeter is exactly locked in, and then you take a picture, and then you nudge it, and then you take another picture, you nudge it. They are getting into more stuff with 3D printers, where they have, instead of modifying the character frame by frame, they have just different faces. So when these characters are going to say something, they just pop on that next face, pop on the next face, and then they can take their picture. So it becomes a little bit easier, but still not for me. I prefer flipbook stuff, which is kind of neat. I prefer some stop motion stuff, which is kind of cool, especially for the learning phase of this. This one was kind of cool that we looked at another day, which is this stop motion pizza making. It's kind of neat. The stop motion Legos, if you ever look at this stuff, I mean, there's people that's all they do all day long. 6 million views for this one, 14 million views for that one. So it's just crazy how Minecraft and Legos, holy cow, kids are exploding. All right, so it's all over the place. So there's lots of resources for it. You can get an app for your phone that'll let you do stop motion stuff. You can get an app for your computer that'll allow you to stop motion stuff. It's very powerful. If you want to work at ILM or Blue Sky or any of these high-end animation studios, they want to see your flip books. They want to see your poses hand-drawn. They want to see all this stuff. Okay, so we're doing this hand-drawn. All right, don't use anything digital. Don't use Photoshop or After Effects or anything. I want to see that kind of stuff. If you get into Flash stuff, Flash has some hand-drawn effects you can do as well. Okay, Mike Campbell. If I go to the desktop, here it is. This is his motion graphics reel. Okay, and this will get us to project management. Like Maya, I wish Maya actually had this, is that you can't start working on anything until you've set your project. okay? Because every time you're working in Maya or in RealFlow, it's writing stuff out, okay? You might get a window that pops up. You want to see these things, just hit close, whatever. This is going to be a playing one, so if you want to put it in a certain spot, you can. You just click the dots for the location, and you pick your D drive. And I'm just going to make a new folder here called RealFlow. Okay, and then once you have that location, give your project name something. I'm doing test board break. Okay, your project is essentially your file, so I keep it as the same thing. You can save multiple files, but I just keep it as, you know, my files basically, projects and files are separate. Okay, so I'm calling it test board break. It's going in my D:/Sarcona 2550 work RealFlow and create. Okay, so I'm going to hit F again and not do that. If you want wireframe, it's 7. If you want whatever that mode is, I never use 8, but that's something. 9 is flat shading, and 0 is smooth shading. Okay. And then if you want to switch between views, perspective, front, top, left, it's 1, 2, 3, 4. So 1 is my top view, 2 is my front, 3 is my side, and 4 is back to perspective. Okay, so 1, 2, 3, 4 for your views, 7, 8, 9, 0 for your shadings. Okay, so we have this cube. It's laid out here. I'm going to break the cube. So under Object Dynamics, you'll see that there's several different fractures on that tab. Okay, everything is accessed through these tabs up top. So under the fractures, there's different ways we can fracture something. We're going to do the simplest one, which is the far left one. Okay, so we click that far left fracture, and this tool comes up. And if you look at the name of it, it's called Voronoi Uniform. Okay, and Voronoi was the same kind of fracturing algorithm plugin that we used inside of Maya to do ours. All right, so just so you know, it's the same kind of calculation. So let's keep it about 150 pieces for now. Okay. Whenever we see the word seed, that means it's basically when you create a random number, it's not actually random. Okay, it's like here is this sequence of digits. Okay, and this sequence of digits is 1427. If I want a different sequence of random numbers, I can type in a different number, and it'll select from a different pool of random numbers. Okay. So that's fine. We leave it the way it is. We hit OK. All right. So once we've hit OK, you can see how quickly it breaks it up. Okay. It's not like the plugin inside Maya where it took like, I don't know, 5 minutes in some cases for this thing to build itself. Now it does look kind of funny. We do have two surfaces on top of each other. It copied the original one. If you look over here in your, I call it the outliner, but it's just your node list. You'll see there's a cube 0, 1, and then there's a cube 0, 1 fractured. Okay, so cube 0, 1 we want to just hide. So we're going to click on it, and then in this node parameters, we're going to go under display and just click the word yes for visible. And that changes the word yes for visible to no for visible. Okay, good. All right. You'll also notice that, and mine anyway, that this looks kind of funny, that it doesn't look like it's a cube that's perfectly flat. Okay, and the reason for that is because I have my smooth selection turned on, or smooth, whatever it is, smooth shading. So if I hit 9, you'll see that it goes to this flat shading instead of smooth shading. Okay, so just be aware that that's just a display thing. That's not actually how it's going to render. All right, so now let's make this thing fall. So I'm going to go grab my cube fractured. I'm going to scroll up to the top, and under Dynamics, I'm just going to simply tell it to be an active rigid body. Okay, so I grab the cube under Dynamics, active rigid body. Okay, this is a dynamic system, so we don't have to go in there and specify, you know, I want this to be active and I want to do, you know, 100 things to it. You just simply turn it on, it's automatically there on every surface. Okay, if I hit simulate now, what's going to happen is it's going to sit there. There's nothing in the world telling it to fall down. So what do we need to add to get it to fall down? Gravity. Okay, so under the daemons, or demons, however you want to say it, I call it daemons. Under daemons is all the different ways that we can interact with this thing. So I'm going to just click on gravity, and there it is. Okay, once you've added gravity or attractor or collisions or any of these things up here, they're automatically added to everything. Okay, everything's dynamic, so everything gets us gravity. We can pull it off, but we'll get into that at another time. So now, if we hit play, which is a space bar, you'll see that nothing's going to happen. Okay? By hitting play, we get no animation except for anything that is keyframed. So if we keyframe something happening, we would get that animation. All right? We have to tell it to simulate. We have to tell it to go through and actually figure out what's supposed to happen. Two buttons we're going to use. The reset right here is after we've already calculated something and we want to make changes, we reset it. And then when we want to actually simulate, guess what button we hit there? Okay. Now the hotkey, because you want to learn the hotkey, is just A to simulate. So we just hit A, and what it's going to do now is it's going to go through and simulate. And you'll see it's giving us a percentage for each frame. So you can hit A and let it simulate. Some of yours might go faster than others. Janelle's is like halfway through hers already. It's just crazy. Depending on how many pieces we have, depending on how close these pieces are together, is all going to depend on how quickly this thing simulates. Now, don't be surprised that once we break this thing, that it starts to go very quickly because there's a lot of pieces away from each other. Right now, they're touching each other, and it's like, oh, well, how do I, supposed to calculate that? Also, it's falling, and it's taking forever. So I'm going to hit A again to reset that, or to stop it. And then I can just hit reset. Okay, so I just hit reset. It goes back to 0. What I want to do now is I want to hold this object together, and I want to hold the object in place. Okay, so I'm going to create a couple pieces of geometry. I'm going to create a cube, and just put this cube on this side. I'm going to duplicate it and put it on the other side. Like that. And those are going to be my holders for this object. So they have to be pretty close to it. They don't have to touch it. They just have to be pretty close to it. The other cool thing about RealFlow is that everything that we're doing, if we decided we didn't want this cube here anymore, we wanted a cube that had 7,000 pieces broken up, all we have to do is delete this cube, go to the cube original one we had, break it 7,000 times, and then just hook the objects back up to it. Okay? So everything we're doing now might be in a low-res one, and we can apply that directly to a high-res one at a later point, which is very awesome. All right. So we're going to use what's called a multi-joint to connect these two pieces together, okay? Or three pieces together. Yes, ma'am. All right. So in order for us to use multi-joint, we have to make these two objects be passive rigid bodies, okay? So I can shift-click both of these, or click both of those. And in the dynamics, I'm going to say instead of it being active, it's a passive rigid body. Okay, so way up top where it says node, it says simulation, that says dynamics, we just go to dynamics and just set it to be a passive rigid body. Even though there's no bells and whistles going off, as we start changing this stuff, there's other things changing down here in the node parameters. Okay, so if I click on this original cube and I scroll down, you'll see that there's nothing inside this list that shows anything with dynamics at all. Okay, there's this one up here, I can make it dynamic, but there's nothing down here. Once I made this other one be active, this rigid body turned on, and I think that's the only one that's going to turn on. I think the volume also turned on. No, the volume was there. Okay, and then once I added these guys, then those ones also had the rigid body turn on as well. Okay, so just be aware that as we start turning stuff on, that other stuff is being activated. Okay, so now what we're going to do is under the object dynamics, we have to make sure we click on the right one. There's a multi-joint, which is like right next to fracture. Okay, so we're going to click on multi-joint, and that's just going to create this guy right here. We're going to ignore him at the origin. We're going to come over here to the parameters, and we're going to choose the objects that are being sewn together. So basically it wants to know which two objects do you want me to find are closely touching, and then create that connection. So under object A, we're just going to click and grab cube 1 fractured. Under object B, we'll grab one of the cubes. Okay, so I grab cube 2. Okay, now if the objects didn't list inside the box, that means they're not passive. So then I would just go and grab them, make them passive, and then it would work. Okay, so now there's a bunch of options here that we can change in a second.
Can you repeat that last part?
So what we want to do is go to object A and choose, so we just click right there, any one. Cube 1 fractured needs to be in here, and then cube 2 is in object B. We could have done cube 3 also. Okay.
How'd you get the
Okay, so what we want to do is we want to preview to see where this connection is happening. Okay, because if they're too far apart, there won't be any connection. So we have to test it out. So that's where this create recreate button is. It doesn't look like a button, but it is. If we just click it, we might see something pop up on here. In my case, I'm not seeing anything. I don't know which one cube 2 is. That one. Okay. So I could adjust this by moving it closer, and then going back to the multi-joint and hitting create recreate. Or I could also take this search distance up. Pointer. So this search distance right here is 0.002. It's looking that far away from the points for this object. So I'm going to make that 0.1, and I'll hit create recreate. Okay. Once I do that, you can see I get these little green locator-y things right on the edge of that. So what would happen now if we simulate this? This is acting like a weld. Okay, it's not acting like glue where it would just eventually fall off. It's acting like a weld, well, a good weld anyway, that's holding in place. Okay, so it's going to lock that area in place for the entire duration of this. So we're going to do the same thing for this other one. All right, so we're going to add another multi-joint, and we're going to load it up for the cube and cube 3 now. And we're just going to keep adjusting it until they lock in, until we see that that multi-joint 2 now has little locators attached to the side of it. Okay, and then once it does, hit A to simulate, just to test it out. Oh, also hit Control S. There is no autosave, so you want to hit Control S to save this. All right, so you see one lapse around the room, and this thing is already done calculating this thing falling down. It's way far down there. And what's really cool about it is that it plays pretty much real time. If I just rewind it and hit spacebar, it's going at a pretty good speed. Okay, whereas Maya, some of those things we'd have to, chug along before it actually calculated. All right, so we're going to need a ground. That should be an obvious thing. We're going to need a ground. So what object should we use for a ground? Plane. Perfect. So a reset, go to your geometry, make a big plane. Okay, and then we have to make this a passive rigid body. When we're dealing with particles, we don't have to change anything as far as active or passive. Particles will automatically interact with every piece of geometry in the scene. Okay, only for these objects that are solid objects colliding with each other, we need to change these things. All right, so we know now that these two things are going to hold it up. The middle is going to fall, and it's going to land on the ground and probably break up into a bunch of pieces. Now we need to hold the rest of it together. So what tool do we know so far that holds objects together? What is it?
Glue.
Not glue.
In Maya, it was glue.
In Maya, what do we know so far in RealFlow? Multi-joint. Okay, so that's what we're going to use. Instead of picking A and B as two different things, we're going to pick A and B as the same center item, that big item, and it's just going to hold itself together. Okay, So we just grab A as the cube fractured, B as the cube fractured. We hit create, and we'll see a bunch of little green things happening. And if we were to simulate, it would just be locked in right there. Okay, I'm 95% sure that if I hit simulate, that nothing bad is going to happen. I'll verify it just to make sure.
You said push simulate after?
You don't have to push simulate. I'm pushing it just to verify that nothing's happening. Okay, the fact that all of these are green means something. Green means they're active. If these turned red, red means that they're no longer holding. Okay, so the fact that all of these are still green and I'm on frame 2, well, 3 I guess would be better. 3 means that these things are still holding this entire shape together. Okay, so I'm just going to reset this. All right, now we're going to go to Multijoint 3 and we're going to scroll down. And where it says Force Max Mode Unlimited, this is where we're going to be controlling this thing breaking. Okay, the maximum force is how much, basically how much strength this glue has. Okay, once we change this, then it's going to be acting as glue. Right now, we can consider it to be a weld, which is like a permanent bond.
I don't have little green things.
Did you hit create?
Yeah.
Okay, so this Force Max Mode Unlimited right now is a super glue hold of a thing it's never going to let go. Okay, when we come down here and we change this Force Max on number 3 to constant, now we're setting limitations to it. Okay, now we're setting the ability to break this thing. All right, so change your Multijoint Force Max Mode from unlimited to constant under the Forces menu. And just so we can see it, I'm going to hit you don't have to hit it. I'm going to hit simulate on mine, and we'll most likely will see all of these green things go from green in frame 1 to maybe they'll go to yellow or orange, and then they'll go to red, maybe. Okay, a lot of this depends on your scene scale too. Right now this is set to 1,000. I've worked in scenes before where it's been up to like 140,000. Okay, and that's the only thing that holds that thing together. So far it looks like it's holding it as far as this coloring. However, I can definitely see that I've broken apart. Okay, and if I scrub in here, you can see that it is breaking. I don't know why the color isn't adjusting, but it is breaking. Okay, so I'm going to take this up to 14,000. Okay, so change your max to 14,000. We're all pretty much at the same scale, so that should be about okay. And then we'll simulate again, and we'll take a look and see if it's holding. Our goal is to get this thing to hold up when we hit simulate, because there's nothing else interacting with it. It should just stay exactly right there. And if it's not, then we're just going to keep upping that max force until we get it to where it's holding. Now we could take the max force up to 758 million, but then we're going to have a pretty heavy ball come down to knock the thing open. Okay. One of the things I was playing with yesterday is I was simulating the same building. I built a building inside Maya, I brought it into RealFlow, and I threw a ball at it and I tried to get the same thing. And it went from being kind of silly, like Legos falling down, into this ridiculous thing where the ball would come and it would hit it, and it would fall down, and then it would shatter into pieces. So you really have to be careful with that max force. Okay, so you can see it's still falling. So I'm going to hit escape, I'm going to reset, and I'm going to add a bit more to this. So let's say, I don't know, 50,000. All right, so let's see. So at 200,000, there's still a little bit of a wobble in there. Holy cow. I might have to actually take the other ones up too. No, those should be good. Those are unlimited. One thing I can do on the other ones is increase their search distance. So I make that 1. You'll see how it kind of goes a little bit further inward than when it was at 0.1. It's very flat. So by increasing multi-joint 1s, increasing multi-joint 2, I'll get a little bit further hold inside there. There's also other settings we can adjust too. It might even be that our calculation just isn't accurate enough, and we could take those up. But I don't want to slow this down any more than it already is. Okay. So we're going to assume wherever we're at now that this is good, and we can always adjust it later. All right. So now all we're going to do is just create a sphere and just put it above it. Okay, so I just made a sphere, scaled it up a little bit so it's, a little bit bigger. And then I'm just going to let it simulate. And we'll see the sphere come down, and it'll crash right into it, and it'll break that thing into a bunch of pieces. Yes, let's make the ball active so that it actually falls. So you make the ball an active rigid body. And I'm going to grab the cube fractured, and I'm just going to take the object friction up to 1 and elasticity down to 0. Okay, elasticity is the bounciness. Get rid of that. Object friction is 1, so it'll be a bit more rougher together. Okay. On the sphere, there's also a mass. Right now it's set to 500. I'll take that up to 1,000 and also increase its friction and take down its elasticity. And then I'll save again and hit A to calculate my stuff.
Did you say the velocity was 1,000?
The mass is 1,000.
Where's mass?
No, on that one the friction is 1. On this guy here, go back. This friction, object friction. Set that to 1. Set this one to 0. And then on the sphere, and scroll up to rigid body. There we go. The mass is 1,000, and then the friction and elasticity are the same thing. 1 and 0. Nope, this object friction. 0. Yep. And then simulate it. Friction is object friction right here is 1. That's fine. You can do that. And there you go. Okay, now we got the sphere. And then the mass is 1,000. And then the object friction is 1. And elasticity is 0. And so far it seems just by taking the friction up, elasticity down, there you go, look at this thing's flying now. It seems to not be falling or breaking. Okay, now it is slowing down once it gets here because now it has to figure out what's it going to do when the ball hits this thing. Eventually it'll get to the spot where it goes a bit quicker. It has to take those first 10 or 15 frames to do that. Okay. Now it's still not going to break the correct way. You can see mine is kind of bowed and it still hasn't really broken. Eventually it's going to break, I think. Yeah, it looks like it's going to break. It seems to be taking its time breaking. All right. Yeah, you can see it's definitely kind of bowing here, but not really breaking the way it should. All right, there's one more thing we have to turn on, so I'm going to stop it and reset it. And this will help speed it up as well once it actually collides. Okay. On the multi-joint, we've set this limit, but we haven't told RealFlow that we want it to be able to break. Okay. So down below the forces, there are these collisions and braking. So I'm going to say enable if break. Yes. break if max force reach, yes. And those two things will basically say if the maximum force of this, 200,000 I think I'm at, 200,000 is reached, then break the thing into pieces, okay? And that's going to be applied to each one of these little locators. Each one of these locators has a special connection, and that basically, if that thing exceeds 200,000, it's going to break. So basically these pieces at the center here will break. These ones here will have less breakage. So we might get more chunks on the outside because we're not having as much force there. So again, we'll save, and then we'll simulate. While we're waiting for this thing to calculate, this guy over here, this is our relationship editor. This thing in the middle is called the hub, okay? And you'll see that all the stuff that we've created in our scene is being piped right into the hub, all right? What that means is that this is the relationship that all of these things share, okay? So everything piped into hub 01 has gravity to it because one of these things, I zoom in, I can see it. Right there under the red one, is gravity, okay? And the plane is here, and so anything that's piped into that will collide with the plane. And anything that's, you know, the sphere is into hub 1, so it'll all connect. So all this stuff is connected, all right? If we added another hub, which we can do, we can have one set of simulation going on here, another set of simulation going here, and then I can have other stuff happening, okay? So think of it like that 2012 thing. We could have one building simulating here, another building simulating here, and they're interacting independently, but then the parts that are going to touch each other, I could have those go to both of them, okay? So I can say, even though you're part of this simulation, I want you to also collide with that stuff. Anyway, so you can see that it broke. In the middle, it's kind of a weird break, but it broke. Now I could, again, go through, take my mass of that sphere up higher, and more force will come down and just shatter the whole thing, okay? It's just a matter of now that we're at, you know, on mine, I'm like at 2 million, I think. I'm at 2 million. So that sphere dropping really has to have a lot of mass in order for it to shatter it more, okay? And it's another cool thing is I can just stop it, and I can see where I'm at and see if I'm liking what I'm getting so far. Okay, that looks kind of weird how it's just stopping. And I can go and just reset. Or I can go to the end and just recalculate more. But I'm going to take this mass up to 10,000. I really want to see this thing just like slam through it and break it. The liquid particles, these are working just like regular particles do. Okay, so we attach particles to our building and that fell. Those are like those kinds of particles. So if we wanted some very basic fluid effects, we could use that. The next one that's over on the left is hybrido. This is the high-end particles. This is much quicker. They interact more like a Bifrost would, where we can fill an object and have it interact, and we can have the foam and the splash and the bubbles and the water line and the mist. All that stuff that we saw was happening when they were showing the coastline and all the building, or all the buildings falling in, all the boats driving by. So we can add all that stuff using hybrido. That's pretty much. We're going to get into some other stuff. There's Real Wave 2, which is supposed to be like a wave simulator. I've only used that once. I've used hybrido a bit and the particles a bit. And you'll see there's different kinds of particles. And there's the other menu, mesh. Okay, so like we did with our Bifrost, is that we created the particles for Bifrost, created the simulation, or would have created the simulation, then we converted it to a mesh. Same thing. So here's where we would create that mesh for hybrido or particles, and then we would bring that mesh into Maya. Okay. Man, this is going slow. RealFlow, it takes OBJs. Okay, so if you wanted to go from Maya into RealFlow, you have to triangulate everything and then save it out as an OBJ. Or you can just save it as a Alembic. Okay, so your regular geometry you'd have in your scene, you can build inside here. So oops, that's a different file. Save. So if I'm building a scene that I want to bring in there, I can just make a plane. I can make a cube. And then I can just go to Alembic Cache, export the selections, or export all. And then in RealFlow, I can just go to import and import those objects right into RealFlow, and there they are, exactly as they were placed inside Maya. And then once I'm done, I would export all that stuff out. Okay.